story I explore in this book. But what about climate change? If we can't predict the weather in the near future, how can we possibly predict climate decades in advance? Although the proposition sounds logical, weather and climate, while obeying the same relatively simple physical laws, are constrained by different variables at different scales, an example of what is called systems analysis. The same system can be controlled and best predicted or explained by different factors at different time and space scales. Sounds illogical, but that is another part of the weather and climate story I find compelling and try to present. There is not a lot of new science here. In fact, one of the central themes of this book is that we have known most of the important facts about weather and climate for a long time. The analogy of a museum with thematic rooms comes to mind, and I propose to be your guide through 4 of these rooms, focused on historical context, the basics of weather and climate, how environmental research is carried out and applied, and how this all relates to our changing climate system. A guide can add value to the works on display by enriching the stories apparent in the works themselves. My role here is to dovetail different parts of the weather-climate story into a single coherent canvas. More specifically, I hope to convey 3 central ideas. The first is that the basic science behind both weather and climate is well known and has been for decades. Although there are remaining mysteries, especially around the role of clouds, the dynamic future of ice, and the impacts on climate oscillations such as El Niño, there is more than enough known to understand the basic patterns and processes and to predict where we are headed. We also understand how we can predict changes in climate over the coming decades, even though the accuracy of weather forecasts fades rapidly more than a week or 2 ahead. Beyond the cold, hard facts, I also try to communicate some of the fascination I feel watching weather and climate unfold, with some basic understanding of why and how we see what we see. The second central idea is that there is a pattern and structure to how we increase our understanding of the workings of the Earth as a single, integrated system through a unique field of research now called Earth System Science. The pattern is similar whether answering the big basic questions about the history and workings of our planet, or how those answers can be applied to environmental concerns. There really are few, if any, aha or epiphanic moments in science at this level. Major questions are resolved through a long period of give and take, measurement, and synthesis. We will discover just how long the timeline can be between crazy idea, initial dismissal, extended research by many, and final resolution. I pay some special attention to the role of computer models, as they have become integral to the understanding and presentation of science, and have been a focus of my own career in science from the very beginning. Finally, all of this background and context about weather and climate, as well as how science happens, are applied to the question of climate change. The point here is that we know enough to understand where we are headed and have known that for some time. My hope is that a guided tour of the science, as presented in this book, can help foster a public discussion of climate change based on a firmer understanding of the science and support a climate debate generating less heat and more light. A note on units. Most of the countries in the world, and all of the scientific organizations and publications, use metric or SI units to express weight, kilograms, distance, meters, temperature, degrees Celsius, and other variables. The United States is essentially alone in using imperial units, pounds, miles, degrees Fahrenheit, for both public and private communications. U.S. agencies like the Weather Service, NOAA, National Oceanic and Atmospheric Administration, and NASA